Hello, welcome to our 15th lecture. This one's on product rule. We're now learning all of these derivative rules. Now, I'm splitting this into two separate lectures. The textbook does product rule and quotient rule together. I'm choosing to do those separate, make those into separate videos. So we're focusing on product rule for this one. And then I will promptly record the quotient rule video right after this. So release them both together. So remember when we took derivatives of a sum or difference, that the derivative behaved really nicely. You could just take the derivative of each individual term. So that allowed us to easily take derivatives of polynomials, for example. When it comes to multiplication, things are not that simple. So if I'm taking the derivative of a product of two functions, unfortunately, it's not the case that I would take the derivative of each individual piece. But instead it works like this. You take the derivative of one piece and leave the other alone, then plus the reverse. I leave f alone times the derivative of g. So you're taking the derivative of one piece at a time and leaving the other part unchanged. For example, we want to find f prime of x, or let's say 4. F of x equals 5x squared minus 1 times 4x plus 3. Now, it is true that we could technically just multiply that out, and then we would get a polynomial, and then we could take the derivative of that normally. But we do want to learn product rule because we will encounter functions that will not be like this. So we do need to learn the rule. Best to practice it now. It's just at this point we've really only learned polynomials, but we'll get to more stuff. All right, so derivative of the first piece would be 10x. Remember, the derivative of minus 1 is just 0 because that's constant. Times just 4x plus 3 left alone. Then plus, now we'll leave this part alone, but take the derivative of the other one, which is just 4. I get 40x squared plus 30x when I distribute the 10x here. Now I'll distribute the 4. And we can combine like terms to finish this problem. Great. Now let's do another one. So I might have said before that we only know the derivatives of polynomials. That's not quite true if I did say that, because we can handle rational exponents as well. For example, a square root or a cube root, etc. Okay. So we're going to practice product rule yet again. Maybe I'll show a little more work this time, just to be crystal clear. Take the derivative of the first piece times leave the second alone. And I'm running out of space. Plus, just 2x minus 3 left alone times the derivative of square root of x minus 1. And I might change that part now just slightly to make life easier. Same thing. X to the 1/2 is the square root, but this will be easier for taking the derivative. So derivative of 2x minus 3 is just 2. It's like the slope of a line. Okay. Now notice the minus 1 doesn't really matter here when I'm taking the derivative because it's just a constant. So I'm really focusing on this part. By power rule, I bring the 1/2 down. And now it's x to the negative 1/2 because 1/2 minus 1. Now, yeah, I think I'll leave this part mostly alone, except I'll distribute the 2. I want to leave this as is for now because it will help with simplifying. I can use exponent rules to my advantage because you can notice with these constants here, I have 2 times 1/2, so those cancel. Notice I have an x times x to the negative 1/2. Well, in that case, you add the powers. So 1 plus negative 1/2. So again, doing it this way just makes it a little easier to simplify. And don't forget this part with the minus 3. Yeah, I might just bring those together now. The 3 times 1/2 is 3 halves. Right, so I was mostly just distributing in that step. And we do have just a couple like terms we can combine. So these cancel. And I have x to the 1/2 left here. Or same thing as square root of x. Yeah, let's deal with this part too. So I have a negative exponent, which means I can move it down as an x to the 1/2, or as a square root down below. And again, I've got some like terms here. They can combine into 3 times the square root of x minus 2. And then this weird term here. And that's the most simplified it gets. I would like to do one more, and then we'll still see this come up a little bit in the next video with quotient rule. but I think three examples might be enough for this video. Find f prime of x for f of x. Inside the parentheses, we have x cubed plus 2x plus 1 squared. Now again, it is possible to do this without using product rule, but we're not going to go that route. We want to learn the rule while we're at it. That's very important to do. So I'm saying, like, I could multiply this all out, and we'll almost get to that point. I think it'll help to write it like this. Just write this times itself. Because that's what it means to square, right? Now this would be a huge mess, but you could technically multiply that all out using the distributive law, but we're going to use product rule. That'll be a good bit easier. So f prime of x, the derivative, is derivative of the first and I'm showing extra work. Once we move beyond this section, I probably won't do this a whole lot. This rule should come pretty naturally to us over time. Then this piece left alone times the derivative of the other piece, which is really the same thing. So notice, because we were squaring this cubic polynomial, notice that these are actually the same thing, right? This term and this term. They're products just written in the reverse order, but when you're multiplying, that order doesn't really matter so much. It's the same thing. So I'm saying that in this case, I can rewrite this as just 2 times the one thing. Let's write the derivative first. And times that polynomial left alone. So again, the reason I do this is because both of these terms are actually the same thing, just written in a different order. So that's why I just say 2 times this thing. This doesn't happen a whole lot, so this is pretty unique. Derivative of this cubic polynomial, we get a 3x squared for the x cubed part. For the 2x part, that derivative is just 2. And derivative of 1 is 0, of course. Now, if we wanted to, we could multiply this out, but I don't want to, is the thing. I don't think that's really necessary. If in your homework it says simplify as much as possible, then I would multiply that out, but I don't think that should be necessary normally. So we typically consider this pretty good. All right. Well, that was pretty short, but I am splitting this section in 2 from the book. Quotient rule we'll spend a little more time on. That's dealing with division. So I'll see you soon in the next video.